Today I will be presenting question 4 on E and F on homework 2. The questions ask you to use Quine's method to prove that each well-formed formula is a contingency. Quine's method is a method of removing one value and replacing it with true or false within the equation. And a contingency is a well-formed formula that has the outcomes true and false. And you can use Quine's method to find these outcomes. So with some contingencies with more than two variables, or well-formed formulas rather, it is easier to substitute two variables with true or false values. So I replace A and B with false because I believe that this will be the quickest route to finding the false outcome. So false implies false, and false implies C implies false. This simplifies down to false and true implies not C. This is because we are comparing each of these to truth tables or to equivalencies that we have been presented with within the class. So false implies false is equivalent to false, and false implies C is equivalent to true, which is according to the equivalencies we were given in the slides, and C implies false, which is not C. This simplifies down to false implies not C, with false and true being equivalent to false, being the reason that it's simplified down. And due to other equivalencies, we know this is false. Now we need to find which values are true, and which gives a true outcome. So we can replace A and B with true to get this outcome. So true implies true, and true implies C, which implies C implies true. True and C implies true. It gets simplified down this far because true implies true is equivalent to true, true implies C is equivalent to C, and C implies true is equivalent to true. Then we get true implies true, and true and C is equivalent to true, which is why it gets simplified down that far. And from our truth table values for implication, we know that that is true. So for E, it is a contingency. Next, we have A or B implies C or A, and not C or B. So for this, I will solve for true first, and I will replace A and B with true. So true or true implies C or true, and not C or true. True implies true and true. It gets simplified down to this because true or true is equivalent to true. C or true is equivalent to true. Not C or true is also equivalent to true. So we can already tell that it's going to be true. But to simplify it down further, we would just use more truth tables and equivalencies, but it is self-evidently true. So for the proving false portion, it's rather difficult, and this one takes a little bit longer. You can do it with one, I believe, but it is much easier to replace all the values with some sort of truth value. You can do with A being true, B being false, and C being false. So true or false implies false or true, and not false or false. So this simplifies down to true implies false and false because true or false is equivalent to true. False or true is equivalent to false. Then it simplifies down to true implies false because false and false is equivalent to false. True cannot imply false according to its truth table, and the interpretation is false. And which of that we have proven that for F is a contingency, and the problem solved. There are many ways you could go about that problem, but that is the route I chose. You can replace B with false at any point. You can replace B with true, C, and any variation thereof with however many you want it to place.